What's up, everyone? This is Bill with BLR Tuning. Today I got a short video for you guys. I did a video a while back showing off Power Commander 6 and the WB2, that's wideband with Autotune, and how to accept trims in Autotune and stuff like that. So today we want to cover more in the C3 software for the PC6. This will work with PC5 and older PC5 as well. But PC5 can obviously use the PC5 software, but PC6 can't use PC5 software. So you have to use this C3 software in order to run it. So I want to show you guys what all this looks like in C3 software when we have wideband 2 with Autotune connected and PC6 connected. Obviously it's a jumbled up mess of wires, but we do have a WB2 and we have power and ground just going into our converter here. So, and then we have it with the CAN bus cable connected to our PC6. So this whole setup, what we're doing right now is for a Honda GROM, but this would be the same no matter what PC6 you're using for what bike, and then the WB2. So what I'm going to show you on how to set up the narrowband output on here, and that narrowband output is the green wire on the wideband. So the green wire that comes off the wideband will connect to the signal wire from the factory O2 sensor, and then you would no longer have that factory O2 sensor hooked up. You would have this green wire hooked up instead. Okay, so depending on what the O2 sensor is, a single wire O2 sensor like on a GROM is easy. You cut that O2 sensor, you hook it up to this narrowband output. Now on something that has like a Z125 or a Kawasaki, a Honda, something like that, you know, that uses a 4-wire or a 3-wire, you're going to have to figure out what is ground and power to heat up the O2 if it's a heated O2 sensor, and you're going to have to figure out which is the signal wire, because that's what the green wire goes to, is the signal wire. It would still need its ground and all of that. Okay, so just keep that in mind. Green wire now will be connected to your signal wire that's coming from the ECU down to where the factory O2 sensor used to be. So we would no longer have the O2 sensor hooked up. Instead, we'd have a green signal wire here. Or green signal wire here would be hooked up to that O2 sensor wire going back to the ECU. Okay, so let me get back here to the software. Okay, so hopefully you guys can see this. The screen record for the computer wasn't working the best, so we're going to try it like this and see what happens here. Okay, so you'll see that you have the WB2 hooked up, and let's say, for example, we are wanting to run as if there is an O2 sensor, so with the narrowband output being used on the wideband. Okay, so to configure that, you will click on this configure wrench right here. This will be grayed out if WB2 isn't plugged in and has power. Okay, so if you're doing this at the computer, you need a power and ground source. That's 12 volts. If you're doing it on the bike, you need the key to the on position and the kill switch in the run position, so wideband has power. Okay, the WB2 needs to see power. Okay, and then the CAN bus cable plugged into the PC6. You click configure, and you'll see this narrowband output switch point 1. If the number is 1, that would equal 14.7 AFR. Okay, you can convert, it's going by lambda value, but you can convert lambda over to AFR. Just look it up online. The charts are all the same as long as you're looking at stoichiometric value for pump gas. Okay, so we have it set at 0.925. That is going to be right around 13.6. So what that means is, what we are saying is that we want the narrowband, the closed loop section of this tune, to run right around 13.6. If this is a big bore kit and it's flowing a lot of air, that's going to be a pretty efficient 13.6 is going to be really efficient and run properly, versus if we put it at 1 at running 14.7, this bike will end up running lean. Okay, so basically we're trying to have it pick up some fuel. Okay, so then we would set our number in here. You'll see this toast message came up when I clicked on that. We'll hit OK. And now that technically sent it over to the wideband. We can confirm that by hitting configure once more. and we should see our number of 0.925. If that number is different, push it in again, hit OK. If it keeps coming up different and the wideband isn't accepting it, unplug the USB cable, let everything disconnect, plug it back in, and try it again. Okay? I haven't had it fail on me, but if it does, that's what needs to happen. Okay, so now our wideband is programmed. So that will be our narrowband output. So we are saying we are going to run a closed loop section and an open loop section. So now we can go look at base fuel. And in our base fuel for the older Honda GROM, so this is like a 2015, I believe. And each bike's going to vary, so you're going to want to do your research, okay? Something like an ATV doesn't really have too much of a closed loop versus open loop section, whereas something like a Honda GROM, CBR 1000, Yamaha R1, BMW S1000RR, Harley, Indian, all of these bikes that I'm mentioning have a closed loop area that the O2 sensor controls, and then an open loop area that can be controlled by Power Commander if you're using a Power Commander 6. So you can see here, then this is just the tune that was on this by default. It's probably just stock, yeah, so stock exhaust, stock intake. So we're going to be building a custom tune for this, but you get an idea here. 60% throttle, okay, 60% throttle, and all the way out. That is the area, and then at right about 8750 or so RPM and down, those areas we can adjust the air to fuel in the tuning in Power Commander 6. The rest of these areas will all stay at 0 because they are being controlled by the closed loop section, which is what that wideband is doing when we configured our narrowband output lambda value. So basically we're saying all of this is going to run at 13.6. So all of this, we're trying to get all of this to run at 13.6. Okay, so all the way down here we'll go down to 8,500 RPM. Okay, so from 0 to 40% throttle, that's your throttle position up here across the top, and then here's your RPM across the side. So now, if we look in target AFR, you can see there's nothing set in here. We will need to set this up. So let's say, for example, if we want it to run at 13.2 out here at wide open, then we would make our fuel AFR adjustments like this, and we can go 13.2, and this is just an example. Okay, this isn't necessarily going to be the best setup in the world, but this is just an example. 13.2. Okay, so now we have AFR numbers at 60 to 100% throttle and at 8,500 RPM and up. Okay, all of the rest of this is always going to be zeros, and in the fuel trims it's going to be zeros because the narrowband output is going to control that area of the tune. Okay, we're relying on that to control it. If we want to add fuel or AFR numbers, we can add fuel, and that's okay. So let's say it has a rough time starting, we can add a little fuel at startup to get it to start, okay, and put it in our base fuel numbers. We can do that. But now if we want Autotune to help us tune in here, Autotune will only suggest fuel trims where AFR numbers are present. So for example, all of this area will never get numbers suggested by Autotune because we're leaving them at 0, and we're all relying on the narrowband output to take control and do its thing. So this is closed loop, and then all of this is open loop. We are only doing the tuning in open loop in this type of map. Okay, so now if we go to up here to configure, and we got Autotune, we want to make Autotune enabled, and it's a single cylinder, so we'll just leave that checked. Engine runtime is 60 seconds, that's fine. Hardware switch is digital input, that's fine. We don't need to use any kind of switch. We're not running any kind of engine temp. We just want it to run at 60 seconds. So after 60 seconds, it's running auto tune. And then 20 max and 20 max enrichment, 20 max and lean. Basically, that means it can request 20% minus fuel or 20% plus fuel. Okay, so we'll hit OK. It's not currently have auto tune tables. Would you like to add those tables? Yes. Okay, so you just saw me set that up. So now we have Auto-Tune turned on, and then we can see Auto-Tune in here. Okay, primary target AFR. So we'll go through and set that up. But you get the idea. That is... So now we need to go like this, the AFR. So we'll go 13.2. And then our 8,500 RPM and up 13.2. Okay, there we go. Okay, so now if we go out and ride the bike and we are coming back from a long ride, we can go in here, plug in the USB cable, hit receive map to receive all the data from the map to the software. And then we can look at our auto tune and see where it's making adjustments. Remember, you're only going to ever see numbers where there is actual AFR numbers. So let's say out here it says 10. Okay, let's say it says that. You see the 10 here that I have highlighted? Let's say we saw that in there when we got back from a ride. Okay, and then we can look at our fuel, and that same spot is at -2. But now, let's say we came back from a ride and our auto tune is suggesting it needs 10% more fuel in that spot to get to 13.2 AFR. Okay? That's what it's suggesting. So it's saying, I'm trying to get 13.2. In order to do so, you need 10% more fuel right here. So we can right click over here on Auto-Tune. So what I like to do is just highlight what we're looking at, right click, accept trims. This will apply all of the Auto-Tune trims to their respective fuel tables and the solution. Do you want to continue? Yes. Okay, so you can see there we accepted our trims, and now this has gone back to 0. And now if we go back to our fuel map, you can see we now have the number of 8. So it was at -2. So +2 would be 0, and then +8. That gives us our total of 10 that it was suggesting to get to our target AFR. Okay? And remember, all this is always going to be zeros because there's no target AFR numbers. If you want it to run a certain way in here, then you need to add AFR numbers in here. If we wanted this little spot, let's say this ends up being where we are cruising at most of the time, and we want it to run a little better, we can put that at 14.4, something like that. Now, Auto-Tune will suggest trim values for this area. Okay? And then our narrowband output will cover all of the rest of the area that is out of the range of what the O2 sensor is capable of. Okay, and then when we're all done in here, remember we need to hit send map. If you didn't hit send map, you didn't do anything. Okay, remember we're talking to the computer right now, and then when we are ready to send everything over to the power commander, we have to hit send map. If we don't hit send map, we didn't make any changes. Okay. Okay, you'll see what happens when I hit receive map here. It's basically telling me that I am going to override everything that I've done in the software because I haven't hit send map yet. So it's going to grab all that data that was on the PC6 and override everything else. So here I would want to select no because I haven't saved my changes yet. If you want to save your changes, send to PC6. I hit no, so I didn't save. So now as you can see, it's just the numbers that are here. All of our everything else did not change. Okay? Because we never hit send map. Anyway, I hope that makes sense to you guys. Hope you guys could follow along there. Hope that helps somebody with the narrow band output and how it works in Power Commander 6 C3 software. To get this software, you need to go to the Dynojet website, look at the download section, and you need to download Power Core Suite, and then you will open C3. Please remember, tuning is for track or off-road use only. If you don't know what you're doing, you should seek some professional help and reach out to somebody that actually knows what they're doing. This is just a demonstration. The tune on this video that you're seeing should not be loaded onto your bike thinking that it's going to get you somewhere. This is all just a demonstration. If you want to check us out, it's blrtuning.co. There'll be a link in the description. You can reach out to us anytime. Have a great day.